So for our final in Mr. Cooper's class, we had to make soap. It was actually an awesome experience, so I thought I'd share it with you. There are two main ingredients for making soap, oil and lye. In class, we use the hot process, meaning a crock pot is used for the chemical reaction, almost cooking the soap. The lye, or sodium hydroxide, reacts with the triglycerides in the oils. This process is called saponification. By using saturated fats, like coconut oil for example, the soap will have good cleaning qualities and will be solid at room temperature. As shown in the diagram, saturated fats have no double bonds in their carbon chain. Each carbon bond is saturated by hydrogen molecules. On the other hand, unsaturated fats have double bonds in their fatty acids. Unsaturated fats are liquid at room temperature. The first thing we did was measure out all of the oils. Our group decided to use 3 types of oil, but 1 is plenty. The type of oil you decide to use brings different qualities to your soap. For example, avocado oil is often used for people with sensitive skin and also gives the product a longer shelf life. Then we started mixing the sodium hydroxide. We added the appropriate amount of lye and water, then mixed it with this cool magnetic plate. It is important to have water in this because it is one of the catalysts in the reaction. As the soap cooks in a crock pot, some of the water will also evaporate, making the soap hard. After everything was ready, we added it all to the crock pot and began mixing. We kept our eyes on the clock, but mainly focused on mixing until the solution was a pancake batter-like thickness. This thickness is called trace, and it's important because we can tell that the reaction has occurred. After a few minutes of mixing, however, we also added a color and fragrance. This determines how the soap will look and smell. After we were done mixing, we poured out our soap into silicone molds. We chose silicone because they were non-stick and flexible. By using a program called Vernier Graphical Analysis and pH probes, we were able to determine the pH levels of our solution. It is important to measure pH levels to determine if the soap is safe to use. If the pH level is too high, it means that there was too much leftover sodium hydroxide in the soap. To prevent something like this from happening, we use a technique called superfatting. By decreasing the amount of lye in the reaction, we are able to ensure that the sodium hydroxide is the limiting reactant in the chemical reaction, so there will be no leftover lye. For example, superfatting by 5% means that we are using 95% of the lye needed for the reaction, leaving some leftover oils. After we knew our soap was safe, it was time to start packaging. We used parchment paper and printed out stickers courtesy of the Edge Lab. One of our soaps was named the Home Depot because it smelled like the inside of a Home Depot store. And that's how we did it. Now let's take a look at some soaps from other groups.